There is a classic mistake that people make when they've just learned this separation trick for solving differential equations. Let me show you what this mistake is. So let's try to use our separation trick on this equation. So in general, our separation trick is try to get all of the y's to the left and all of the x's to the right. So we could subtract y from both sides. That would give us dy dx minus y equals x. Okay, but we don't have all our x's on the right because there's this dx on the left here. And so here's the mistake that people often make. What I see people do is they just sort of magic the dx over to the right-hand side. But you can't just move it over like that, right? In the past, when we've moved the dx to the right-hand side, there's an algebraic process that we went through. And the algebraic process was we multiplied both sides by dx. Right? That's how we got the dx to the right-hand side. And if you actually do that algebra, the right-hand side does turn out to be x dx, but the left-hand side turns out to be dy minus y. Now, this might not seem like a problem at first, but if you try to integrate, on the right-hand side, this integral is no problem. Integral of x dx is 1/2 x squared plus a constant. But what about the left-hand side? Now, this part right here, the integral of dy, that's just y. But what's the integral of y? Well, you can't integrate y by itself. For an integral to make sense, it has to have a differential with it. And there's no way to integrate this y because it doesn't have a differential to make the integral make sense. So this doesn't make any sense, right? Doing this doesn't make any sense at all, right? Another common mistake in this situation is to just sort of ignore that this doesn't make sense and say that, well, integral of dy is y, and then the integral of y is 1/2 y squared. But there wasn't a dy here, and so you can't actually integrate like that. So all of these problems that we ran into happened because we're trying to force an equation to be separable, or we're treating this equation as if it's separable when it's actually not separable, right? Remember, a separable equation is an equation that looks like dy dx is some function of x times some function of y. But this function, or this right-hand side of this equation, y plus x, no matter what algebraic trickery you try to go through, you can never make this look like a function of x times a function of y. It just doesn't work. Another algebraic mistake that people sometimes make is, right, they see that it's not a function of x times a function of y, so they try to sort of rewrite it. They maybe factor out a y, and then they say, well, y times 1 plus x. But this is an algebra mistake because y times 1 plus x is not the same thing as y plus x, right? If you just multiply it back out, you don't get back to where you came from. So this equation, the only way to make it separable is by making an algebra mistake, which definitely is not something you want to do. So this kind of equation, we cannot solve this with our separation trick. This is an issue that we're going to run into again and again. Differential equations, there's no general all-purpose trick for solving differential equations. For specific types of equations, there are tricks that work, but a trick that works for one kind of equation will not work for a different kind of equation. So you always have to sort of understand what kind of equation you're working with before you dive in and start trying to solve. This equation is not separable, and so we shouldn't even try to use our separation trick because it's not going to work.